Okay, hello. So I'm just going to try and use this little demonstration here and show you a little bit about frequency and amplitude. Okay, so if we just start off with a reasonably slow wave, 1 Hertz, I'm just starting that wave now, and you can see the buildings are moving gently backwards and forwards as it's a sine wave. If we just take our attention to the screen, which is the output of an oscilloscope, I'm just going to stop it there so we can have a look. So the frequency is basically defined as the number of waves per second, and we can see that by looking at where the rise of the sine wave crosses the zero axis. So it's crossing there, which in this case is about 0.5 of a second, and then we wander around until it crosses the zero axis again, which is around here, which is about 1.5 of a second. So from here, just on the screen, to here is about 1 second in between the two, which makes a lot of sense because it's a 1 Hertz wave. So if we do 1 divided by 1, we get 1 Hertz. So if I double the frequency now and start the oscilloscope again, catch some of the wave, you can see here that if we look here, we've got roughly 0.6 of a second, and we go back down, and where it crosses the zero axis again on the rise, we can see that we've got about 1.1, because we're halfway between the box. So the difference between those two is 0.5 seconds. So if we do the 1 over the period again, 1 divided by 0.5 is obviously 2, and that's how we've got our 2 Hertz frequency here. So hopefully that gives you a little understanding or reminder of what frequency is. And obviously, as we increase the frequency, we're effectively shortening the wave against the time base. So if I increase it again, so now it's at 3 Hertz, I've got to be a little bit careful of my buildings up there. And if I drop it down to 2 Hertz, it's not the cleanest transition, but we can see. And 1 Hertz, it's very slow again.